backside. Okay, so this is similar to number 1, right? And so like we were saying there, these events are going to be disjoint. I can't get a black marble and get a red marble at the same time. So 6 should be A. For number 7, they're asking us the probability of drawing a queen or a diamond from a standard deck of cards. So the probability of queen or diamonds is going to be equal to the probability of a queen plus the probability of a diamond. And so the question here is there any overlap? Do I need to subtract anything out? And the answer is yes, there is. There is the queen of diamonds. So how many queens are there? It's going to be 4 out of 52. 4 queens. How many diamonds? There's 13 diamonds. And then there's that 1 queen of diamonds. So when I do this math here, I get 17 over 52 minus the 1 over 52. So that's 16 over 52. Sorry about that. Which reduces down. I can divide both of those by 4. So I get 4 over 52 divided by 4 is 13. So that gives us an answer of B. Alright, number 8. So each student casts 1 vote for senior class president. Of the students, 30% voted for Sam, 35% voted for Jack, and 35% for Anne. Student from the senior class is selected at random. They want us to know, or they're asking us, are the events of voting for Jack and voting for Anne, are they disjoint or overlapping? Well, with your 1 vote, you can't vote for both of them at the same time. So that means there is no overlap, and therefore the events are disjoint. And so now in number 9, we actually need to figure that out. So the probability of voting for, who was it, Jack or Anne, is equal to the probability of voting for Jack plus the probability of voting for Anne. Notice now I don't need to minus anything here because there's no overlap. So Jack had a percentage of 35, and Anne had a percentage of 35 also. So if I add that up, I get 0.7, or you could write it as 70%. And as a fraction, of course, that would be 7 over 10. Either way, all of them are good. Alright, number 10. Jump ropes are given out during gym class. A student has a 1/6 chance of getting a red jump rope and a 1/3 chance of getting a green jump rope. Jane is given a jump rope. What is the probability that Jane gets a red or green jump rope? So again, in this case, the probability of red or green is equal to the probability of red plus the probability of green. And is there any overlap? Can Jane get a jump rope that's both red and green? No, so I don't need to worry about any overlap here. So these events are disjoint. So the red is going to be 1/6 plus 1/3, and if I convert that, I'm going to have 1/6 plus 2/6, which adds up to 3/6, which adds up to, reduces down to 1/2. And that would be answer choice C. All right.